In the last lesson we learned what a network is. Now we get a map for how networks actually work, the layered models. There are two, the 7-layer OSI model and the 4-layer tcpip model. Don't worry, this is far less scary than it sounds, and by the end you'll use these layers as a practical tool to find faults fast. Networking is complicated, so engineers split it into layers. Each layer has just one job, and it only talks to the layer directly above and below it. There are two models to know. The 7-layer OSI model is the teaching and troubleshooting reference. The 4-layer tcpip model is what the real internet runs on. You don't need to memorize every detail. You need to use the layers as a map. Here are the 7 layers from the bottom up: physical, data link, network, transport, session, presentation, application. A classic memory aid is please do not throw sausage pizza away. The bottom layers are hardware and wires. The top layer, application, is what the user actually sees, like a web page or an email. 3 layers matter most for Helpdesk work. Layer 2, data link, is switches and MAC addresses, moving data on your local network. Layer 3, network, is IP addresses and routers, choosing the path between networks. And Layer 4, transport, is TCP and UDP, delivering data end-to-end using port numbers. Most of the problems you'll troubleshoot live right here. The real world uses the tcpip model, which collapses those 7 into 4. Network access covers OSI layers 1 and 2. Internet is layer 3, where IP lives. Transport stays as layer 4. An application rolls up layers 5, 6, and 7. It maps cleanly onto OSI, so once you know one model, you understand the other. As your data travels down the stack, each layer wraps it with its own header. This is called encapsulation. At transport, your message becomes a segment. Add an IP header and it's a packet. Add a MAC header and it's a frame. Finally, it's just bits on the wire. The receiving device unwraps each layer in reverse. Knowing those words, segment, packet, frame, helps you read tools later. Here's the real payoff. When a user says the internet is down, you work the layers. Ping your gateway to test the local network. Ping 8.8.8.8 to test reaching the internet by IP address. Then run NS lookup to test names. If you can reach 8.8 but not a website name, the link is fine and the problem is DNS, up at layer 7. The model tells you exactly where to look. Let's walk one through. If the cable is unplugged, every single ping fails. That's a layer 1 physical problem. If you can ping your gateway but not 8.8.8.8, the local network is fine and the issue is routing or your provider. And if you can ping by IP but website names don't resolve, it's a DNS problem. Each pattern points to a layer, and that turns guessing into method. Let's recap. The OSI model has 7 layers, and tcpip folds them into 4. Data is encapsulated layer by layer as it goes down the stack. And the real value is troubleshooting: localize the fault to a layer, then fix it. Your task: write out the 7 layers from memory using the pizza mnemonic, name one device or protocol for each, then run the ping and NS lookup commands and note which layer each tests. See you in the next lesson on IP addressing.